Hi, this is take two. Hopefully this video will work about my science lab lesson plan. This is from Next Generation Science Standards. Develop and use a model to describe waves are reflected, absorbed, and transmitted through various materials. And the disciplinary core idea that the path light travels can be traced in straight lines except at surfaces between transparent materials where light path bends. So students will conduct an experiment about how light is reflected and or absorbed and construct an argument in a written text using evidence obtained through the experiment. And in my anticipatory set, obviously I'm not in a classroom, so I'll just walk you through it. The teacher is going to review the notes from the previous lesson with definitions on reflection, refraction, and absorption of light. And I have a humorous video clip. It's about 1.5 minutes. It's a guy it's from the Red Green Show, and he's trying to spearfish, but he can't figure it out because the stick is being refracted in the water, and it's just kind of a humorous way to open the lesson. It's kind of funny. And there's a few safety tips in there that we can talk about too. And so then the teacher will start off with a couple mini demos. One of them is for students to look at something in a glass of water, like a pencil or a straw, or I have a chopstick here, and notice how that at the surface of the water, the object appears broken because of the way the light is interacting with the medium. And students will write their observations and their questions about that. I call them wonder questions in their science notebooks. And then show them a piece of paper with some arrows. And noticing that when the glass is empty, you can see both arrows clearly. But when you put water in the glass, it looks like the arrow is facing the other way. And I'm not sure if you can see it here, but I don't know why it worked when I did it, and I don't know why it's not working now. So yeah, it's really difficult to get this all on camera. So then again, the wonder questions in their science notebook, and we'll review the difference between reflection and refraction, and I can do a TPR response by having students think about this demo and whether it represented a refraction of the light or a reflection of the light. And if they think it's reflection, they can hold up the letter E. If they think it's refraction, they can hold up the letter A. And then I can have an instant assessment, kind of formative assessment of who might need a little bit more help with the concept. So then I'm going to introduce the guiding question, what happens when light waves meet various materials, and I'm going to show them some different materials that light could possibly be affected by. This is actually opaque glass. I have some clear glass. I have some kind of wavy kind of glass. I have blue glass. I have all kinds of different types of glass that they'll be able to look at and write a hypothesis in their notebook about what might happen to light when it encounters such a substance. So safety guidelines next. Because we're going to be working with lasers, it's important for them to know that you never, ever, ever point a laser at somebody's eye. They must always be aware of the path of their laser light and keep control of it. Also, because we're working now, these are pointy glasses. In a real classroom, I wouldn't be using these, but this is what I had at home. And so just be aware that there might be edges that are a little bit sharp, and they should either wear gloves or handle them carefully and always walk with their materials. So very important safety rules. I have them working in groups of 2 or 3. The supplier will get all the supplies, and then I'm going to put the instructions up on a smartboard for their activity. Oh, by the way, this is what was supposed to be written on the board, which is their question. And so the instructions say to set up your graph paper like this, where you draw a circle and then you have an X and Y axis. And in quadrant 1 and quadrant 3, they're going to mark every 5 degrees of angle from 0 to 90. And then they're going to mark the y-axis 90 as the normal. So this is going to be the reference point, the normal, and this is the point of origin, which every trial, their laser light must go through the point of origin to measure what happens to the light. So I'm not sure if it'll work holding it up like this, but I don't have anybody to hold the camera for me, so I'm going to try it. So their glass piece, whatever they choose, goes above the line, and then they can take the laser light and shine it through the point of origin. And it's going to blink because I'm not, it's used for construction, but this is the laser light that I have. And ideally what's going to happen is that they're going to see that the angle of incidence, which is the angle that the light enters the medium, is going to be different than the angle of exit, which is the angle of refraction, which will be closer to normal. It will always be closer to normal than the angle of incidence. So they're going to record data on their recording sheet, at least 5 trials for each of the substances that they choose. I could put out different substances too and have them, or they can think of their own, depending on what we have in the classroom. And some questions I might ask them would be, what do you notice about what happens to the light when the light beam enters the glass? Hopefully they'll see that it bends. If the video that I linked has a much better thing that I would probably do for real in the classroom, which has a semicircle of thick plastic, which is a much better demonstration, but I could not figure out how to make those at home. So does it happen with all types of glass the same way? Why or why not? And have you discovered any patterns in your data? What can they tell you about how light behaves when it meets the material? What does the angle of incidence, how does the angle of incidence compare with the angle of refraction in a single incident? Hopefully they'll see that it's nearing normal. And why do you think this is? And then what other materials would you like to try, and what do you think the results would be? So then at the end, the teacher will ask them to revisit their hypothesis that they made in step 2, I think it was, where they would say, I think this will happen when light hits this material. And so they'll revisit those, revise them if they need to, use support from the experiment, what they learned, and then they will then use that information and vocabulary from the word bank to write an argument about what they think is happening when light is hitting this medium. Some questions I might want to pose at the end are, what findings can you report from your experiment? What revisions would you make to your hypothesis after conducting the experiment, and why? And what argument can you reasonably make for what happens when light meets a particular material? So in the closing, I'm going to revisit the lesson objective, and then try to get them to extend it by asking them what other questions they might have related to the experiment, like other materials or other types of light, or like a flashlight. How can they think about those other variables that we might take into consideration for a future exploration? And then do a little bit of self-assessment where they think about their participation with their group, and how they maybe one more thing they'd like to know. So engaging in that self-assessment just helps them think about their interactions with others and their participation. So I think that's it for my lesson. Thank you.